Orbiting the red giant. Living on Betelgeuse. Hello, everyone. Welcome to Space Explorer channel. Have you ever wondered what it would be like to live on a red giant star? Betelgeuse, one of the brightest stars in the night sky, is a red giant and could potentially be our home one day. Scientists are currently researching the possibility of human life being able to exist on and around this star. In this video, we'll explore the concept of orbiting Betelgeuse, the potential for human life in its environment, and how living in a red giant star system might be different from our current home on Earth. Living on Betelgeuse might sound like a crazy idea to some people, but it's actually something that's been talked about for years. Betelgeuse is a red giant star, and with recent advances in space exploration, the idea of living around it isn't as far-fetched as it used to be. This video will explore what it would be like to live on a planet orbiting Betelgeuse, and what challenges and opportunities come with living in such a unique environment. Have you ever dreamed of living on a distant star? Well, it may soon become a reality. Betelgeuse is a red giant star located about 600 light-years away from Earth. Recently, scientists have suggested that it may be possible to build habitats on the surface of this star. This video will explore the possibilities of living on Betelgeuse. From potential challenges to unique opportunities, we'll discuss what life may be like if we were to live on this fascinating red giant. So grab a cup of coffee and join us as we explore the exciting possibilities of life on Betelgeuse. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. The basics of Betelgeuse. Betelgeuse is a star that has captured the fascination of astronomers and stargazers alike for centuries. Located in the constellation Orion, Betelgeuse is one of the brightest stars in the night sky. But what exactly is Betelgeuse, and why is it so intriguing? To understand the basics of Betelgeuse, we must first delve into the world of stellar classification. Stars like Betelgeuse are classified based on their color, temperature, and size. Betelgeuse falls into the category of a red giant star. This means that it has exhausted its core hydrogen fuel and has begun to expand and cool, causing its outer layers to become swollen and reddish in color. Betelgeuse is not only fascinating due to its classification as a red giant star, but also because of its sheer size. In fact, it is one of the largest known stars in the universe. To put it into perspective, if Betelgeuse were to replace our Sun, its surface would extend beyond the orbit of Mars. But what does this mean for the potential of human life on Betelgeuse? While it may seem appealing to imagine ourselves living on a star, the reality is quite different. The extreme conditions found on Betelgeuse would make it inhospitable for life as we know it. One of the most notable challenges of living on Betelgeuse is the star's intense heat. As a red giant, Betelgeuse's outer layers are incredibly hot, with temperatures reaching up to several thousand degrees Kelvin. This extreme heat would make it impossible for human life to exist on the star's surface. Additionally, Betelgeuse experiences frequent and violent eruptions, known as stellar winds. These winds, composed of charged particles and plasma, can reach speeds of up to hundreds of kilometers per second. The force of these winds would pose a significant danger to any potential inhabitants, making it virtually impossible to safely live on Betelgeuse. Furthermore, the gravitational pull of a star as massive as Betelgeuse would be immense. This would have a dramatic impact on the behavior of nearby celestial bodies, potentially disrupting any stable orbits that might exist. This instability would make it challenging to establish and maintain any form of infrastructure or technology in such an environment. Furthermore, the intense gravitational pull of Betelgeuse would cause significant time dilation. Time would pass much more slowly near the star compared to distant locations, making communication and coordination between potential inhabitants extremely difficult. Another factor to consider is the high levels of radiation emitted by Betelgeuse. The star releases a vast amount of energy, including X-rays and ultraviolet radiation, which would be detrimental to living organisms. The constant exposure to such radiation would be lethal to humans and other forms of life. Moreover, Betelgeuse's unstable nature poses a threat in itself. It is known to undergo sporadic bursts of brightness and irregular pulsations, potentially leading to violent explosions called supernova. While it is uncertain when Betelgeuse will explode, when it does, it will release an enormous amount of energy, enough to potentially wipe out any nearby celestial bodies. This potential supernova event has intrigued scientists and astronomers, as it could have significant implications for our understanding of stellar evolution and the impact of such explosions on the surrounding universe. The explosion of Betelgeuse could result in the formation of a neutron star or even a black hole. This event would release an immense burst of energy, radiating in all directions and potentially affecting neighboring stars and planetary systems. The study of Betelgeuse and its eventual fate contributes to our broader understanding of the life cycle of stars and the dynamics of the universe. As we continue to explore the mysteries of space, Betelgeuse serves as a constant reminder of the awe-inspiring beauty and power of the cosmos. What happens when a star becomes a red giant? Stars, like Betelgeuse, go through fascinating transformations throughout their lifetimes. But what exactly happens when a star becomes a red giant? To understand this process, let's start from the beginning. Stars are born from clouds of gas and dust, known as nebulae. Over time, the gravitational forces within these nebulae cause the gas and dust to collapse inward, forming a dense core. As the core continues to collapse, the pressure and temperature at its center increase, eventually reaching a point where nuclear fusion can occur. Nuclear fusion is the process by which stars generate energy. In the case of our Sun, hydrogen atoms are fused together to form helium, releasing an immense amount of energy in the process. This fusion reaction provides the energy that sustains the star and keeps it shining brightly. However, as a star ages and consumes its hydrogen fuel, a series of changes begin to take place. The core of the star contracts under the force of gravity, causing the temperature and pressure to rise. As a result, the outer layers of the star begin to expand and cool, giving the star a larger size and a reddish hue. This is how a star transitions into a red giant. During this phase, the star's core begins to burn helium, fusing it into heavier elements such as carbon and oxygen. The energy released during this process causes the outer layers of the star to expand even further. As the star continues to expand, its surface temperature decreases, giving it a cooler appearance compared to its earlier stages. For stars like Betelgeuse, this transformation into a red giant is an awe-inspiring sight. Its outer layers have swelled to such an extent that if it were to replace our Sun, its surface would extend beyond the orbit of Mars. Imagine the sheer scale of this giant star and the dramatic changes it undergoes. But what happens after a star becomes a red giant? Eventually, the fusion reactions in the core of the star come to an end. The star runs out of helium fuel, causing its core to collapse even further. This collapse leads to an increase in temperature and pressure, allowing heavier elements like carbon and oxygen to undergo fusion. At this stage, the star enters its final phase of life, known as a planetary nebula. The outer layers of the star are expelled into space, forming a colorful cloud of gas and dust. The core of the star, now known as a white dwarf, remains behind. Over millions of years, the white dwarf will slowly cool and fade away, leaving behind a remnant of what was once a vibrant and massive red giant. Living on a red giant, challenges and possibilities. Living on Betelgeuse, or any red giant star for that matter, poses a myriad of challenges for human existence. The extreme conditions found on a red giant would make it inhospitable for life as we know it on Earth. However, as humans, we are always looking for new frontiers to explore and conquer. So let's dive into the challenges and possibilities of living on a red giant star like Betelgeuse. One of the most significant challenges of living on a red giant is the intense heat. As a red giant star, Betelgeuse's outer layers are incredibly hot, with temperatures reaching several thousand degrees Kelvin. This extreme heat would make it impossible for human life to exist on the star's surface. Any form of unprotected exposure to these temperatures would be fatal. Therefore, humans would have to find ways to live in protected environments or in orbit around the star. Another challenge is the frequent and violent eruptions, known as stellar winds, experienced by red giant stars like Betelgeuse. These winds, composed of charged particles and plasma, can reach speeds of up to hundreds of kilometers per second. The force of these winds would pose a significant danger to any potential inhabitants, making it virtually impossible to safely live on the star itself. However, it might be possible to create habitats or structures that can withstand the force of these winds in orbit around the star. Furthermore, the gravitational pull of a star as massive as Betelgeuse would be immense. This would have a dramatic impact on the behavior of nearby celestial bodies, potentially disrupting any stable orbits that might exist. This instability would make it challenging to establish and maintain any form of infrastructure or technology in such an environment. Additionally, the gravitational forces could also cause gravitational tidal forces that may tear apart any object that comes too close. This means that any form of settlement or infrastructure would need to be carefully designed and located to avoid the destructive effects of gravity. Despite these challenges, there are also possibilities for life on a red giant. One possibility is the existence of habitable zones or regions where conditions might be more favorable for human life. While these habitable zones might be further away from the star's surface, it could still provide opportunities for colonization and exploration. Additionally, advances in technology and the development of advanced spacesuits or protective gear could enable humans to safely venture onto the surface for limited periods of time. Living on a red giant like Betelgeuse would be a daunting endeavor. The challenges posed by the extreme heat, violent eruptions, and immense gravitational pull are not easily overcome. However, as history has shown, humans are capable of overcoming seemingly insurmountable obstacles in their quest for exploration and discovery. While living on a red giant might still be far beyond our reach, the possibilities are exciting to consider. Who knows what the future holds? Perhaps one day we will find a way to make a red giant our home. Until then, let's continue to explore and dream of the possibilities that lie within the vast expanse of the universe. As we delve deeper into the mysteries of the cosmos, our understanding of red giants and their potential for sustaining life may grow. Scientific advancements and technological innovations could open up new avenues for exploring and colonizing these colossal stars. We may discover ways to harness the immense energy radiated by red giants, providing a sustainable source of power for human settlements. Perhaps future generations will develop methods to shield against the extreme temperatures and erratic stellar winds, creating safe and habitable environments on the surface of these giants. With every passing year, our knowledge of the universe expands, and the realm of possibilities expands with it. So, let us never cease to dream and explore. For the red giants, with their challenges and possibilities, beckon us to embark on a journey of discovery like no other. Colonizing Betelgeuse, technology and infrastructure. In order to even consider colonizing Betelgeuse, a red giant star, we would need to develop groundbreaking technology and infrastructure that could withstand the extreme conditions of such an environment. The challenges of living on a red giant are immense, but with determination and scientific innovation, humans may one day find a way to call Betelgeuse home. One of the key technological advancements needed for colonizing Betelgeuse is the development of advanced spacesuits or protective gear. These suits would need to be designed to withstand the intense heat on the star's surface, which can reach several thousand degrees Kelvin. They would also need to provide protection against the stellar winds, composed of charged particles and plasma, that can reach speeds of up to hundreds of kilometers per second. The creation of such suits would require advancements in material science and heat-resistant technologies, ensuring that astronauts can safely venture onto the surface of Betelgeuse for limited periods of time. Another critical aspect of colonizing Betelgeuse is the establishment of suitable habitats or structures in orbit around the star. These habitats would need to be able to withstand the immense gravitational pull of Betelgeuse, as well as the gravitational tidal forces that can tear apart any object that comes too close. Engineers would have to carefully design and locate these structures to avoid the destructive effects of gravity. In addition to creating protected habitats, establishing sustainable infrastructure would also be essential. This infrastructure would need to provide essential resources such as food, water, and energy for the inhabitants. Given the extreme conditions of Betelgeuse, traditional methods of resource extraction and generation may not be feasible. Therefore, scientists would have to develop innovative solutions, such as advanced farming techniques that can thrive in high temperatures, or renewable energy systems that can harness the star's energy. Transportation and communication systems would also be vital for a successful colonization mission. Spaceships capable of withstanding the intense gravitational pull and stellar winds would need to be developed to transport supplies, equipment, and personnel to and from Betelgeuse. Additionally, advanced communication technologies would be necessary to establish and maintain contact between the colony and Earth. Overall, colonizing Betelgeuse would require a synergy of scientific disciplines, including engineering, material science, biology, and communication technology. It would be a monumental endeavor that would push the boundaries of human innovation and exploration. While the challenges may seem daunting, humans have a history of overcoming obstacles and achieving the seemingly impossible. Colonizing Betelgeuse would not only pave the way for the survival and expansion of our species, but could also lead to groundbreaking scientific discoveries. The unique environment of a red giant star could provide valuable insights into stellar evolution and the processes that occur within these massive celestial bodies. Scientists could study the intricate dynamics of red giants, gain a deeper understanding of the universe, and expand our knowledge of astrophysics. Culturally, the colonization of Betelgeuse would be a significant milestone in human history. It would represent the pinnacle of human exploration and our ability to adapt to and conquer even the harshest environments. It would inspire generations and serve as a testament to the indomitable spirit of humanity. The impact of living on Betelgeuse, scientific discoveries, and cultural changes. As humans embark on the ambitious endeavor of colonizing Betelgeuse, a red giant star, the potential impact of living on such a celestial body is immense. Not only would this mission push the boundaries of scientific innovation and human exploration, but it could also lead to groundbreaking scientific discoveries and cultural changes. One of the most significant scientific impacts of living on Betelgeuse would be the opportunity to study and gain a deeper understanding of stellar evolution. Red giant stars like Betelgeuse are in a critical phase of their life cycle, and by observing and analyzing the dynamics of this massive celestial body up close, scientists could unravel the intricate processes that occur within these stars. This newfound knowledge could revolutionize our understanding of astrophysics and contribute to our understanding of the universe as a whole. Furthermore, living on Betelgeuse would provide a unique vantage point for astronomers and astrophysicists to study the cosmos. Being in such close proximity to a red giant star would allow for detailed observations of other celestial bodies and phenomena, offering unprecedented insights into the workings of the universe. This could lead to new discoveries and breakthroughs in our understanding of cosmic events, such as supernovae, black holes, and the formation of galaxies. In addition to the scientific impact, the colonization of Betelgeuse would undoubtedly bring about significant cultural changes. This monumental achievement would represent the pinnacle of human exploration and resilience, inspiring generations and showcasing the indomitable spirit of humanity. The ability to adapt to and conquer even the harshest environments would leave an indelible mark on our collective consciousness and foster a sense of unity and pride in our species. The colonization of Betelgeuse could also lead to the development of a unique and vibrant culture. As humans adapt to the extreme conditions of living on a red giant star, new traditions, customs, and artistic expressions would emerge. The challenges faced by the colonizers would foster a spirit of innovation and collaboration, resulting in the development of new technologies, art forms, and societal structures. Moreover, the cultural exchange between Earth and the Betelgeuse colony would enrich both societies. The knowledge and perspectives gained from living on a red giant star would challenge conventional wisdom and expand our understanding of what it means to be human. This exchange of ideas and experiences would stimulate intellectual and cultural growth, fueling innovation and creativity in both worlds. In conclusion, the impact of living on Betelgeuse, a red giant star, would be profound both scientifically and culturally. The scientific discoveries made possible by studying this massive celestial body up close could revolutionize our understanding of astrophysics and the universe. Simultaneously, the colonization of Betelgeuse would serve as a testament to human resilience and ingenuity, inspiring future generations and fostering cultural growth and exchange. While the challenges are immense, the possibilities that lie within the vast expanse of the universe are boundless. Living on Betelgeuse would also present opportunities for technological advancements. The extreme conditions of the red giant star would require the development of advanced infrastructure, energy systems, and protective measures to ensure the survival of the colonizers. These innovations could have practical applications on Earth, leading to advancements in renewable energy, sustainable living, and space exploration technology. Additionally, the colonization of Betelgeuse would inspire a renewed sense of wonder and curiosity about the universe, fueling public interest in space exploration and science. This increased enthusiasm could lead to increased funding and support for scientific research, further accelerating our understanding of the cosmos. Overall, living on Betelgeuse would have far-reaching implications for science, technology, and culture, offering both challenges and opportunities for the advancement of humanity. Scientifically, studying the extreme conditions of Betelgeuse could lead to breakthroughs in fields such as materials science and engineering, as researchers would need to develop new materials and technologies capable of withstanding the intense heat and radiation. This could have applications in various industries on Earth, ranging from aerospace to energy production. Culturally, living on Betelgeuse would foster a sense of unity and cooperation among the colonizers, as they would rely on each other for survival in such a hostile environment. This could potentially lead to the formation of a tight-knit community, where individuals work together towards a common goal. The shared experiences and challenges would also create a sense of identity unique to the Betelgeuse colony, resulting in a rich cultural heritage that would be passed down through generations. Most of the stars in the universe are main sequence stars, those that convert hydrogen into helium in their cores via nuclear fusion. Over the course of their normal lives, the outward pressure of fusion inside main sequence stars balances out the inward pressure of gravity. Once the core fusion stops, however, gravity takes over and begins compressing the star. This raises the internal temperature of the star and ignites a shell of hydrogen burning around the inner core. Swinburne University of Technology in Australia wrote in a Stellar Evolution Explainer. Meanwhile, the helium core continues to contract and increase in temperature, which leads to an increased energy generation rate in the hydrogen shell. The explainer continues. This causes the star to expand enormously and increase in luminosity. The star becomes a red giant. Red giants' core temperatures, however, continue to rise as the core contracts further, eventually reaching levels where helium fuses to form carbon. This is known as the triple alpha process because it involves 3 helium-4 isotopes or alpha particles. If the star is at least 2.2 times more massive than our Sun, helium to carbon ignition is a relatively gradual process. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.